Well, I'll tell you what, we've really battled a lot of parabolas. We've shifted them, and we've reflected them, and we've dilated them, and all sorts of things. We're going to graduate to circles today. And the first thing I want to talk about is the fact that not all quadratic relationships. Now, when I say quadratic relationships, I'm referring to those involving squared quantities, okay? Now, as far as a parabola, that only has one squared quantity. But what we're going to learn today is that not all of these quadratic relationships are actually functions. In other words, they don't all pass the vertical line test. So an example of such is the equation of a circle. And a circle, as we're about to find out, has two squared quantities as opposed to just one squared quantity like a parabola does. So here's a monster discovery exercise, and it's going to be a little challenging here. So I want you to have an open mind and see if you can make some sense out of this bear. What we've got cooking here is they drew a circle with a radius of 5 right there. So you know what, I'm going to go ahead and I'm going to label that right now. We got a radius with a length of 5. Beautiful. Okay, and in the center is at 4, 2. Okay, in other words, we went over 4 units, up 2 units. And then there's this arbitrary point on the circle. So assuming you started at the origin, you walked to the right x units, and then we walked up y units. Now they want us to recognize or identify the length that the binomial x minus 4 represents on the right triangle. So here's the tricky part. Now remember, this was 4 units right here. Then the entire thing right here was x units. So if I subtract the 4 from the x, I'll be left with just the side of the triangle. So let me try to show that again. Alright, that's 4 units. If I start at the origin, that's x units. So I got x there and a 4 there. If I subtract those two, I'll be left with this length right here. So that's my x minus my 4. And then they want to say, what length does the binomial y minus 2 represent on the triangle? Well, okay, here's 2 units right there. This is y units, all the way up and down. So if I subtract the 2 away from the y, I'll be left with just that triangle right there. And so let's go ahead and say that this side right here has a length of y minus 2. And if that kind of went over your head a little bit, don't worry about it. I don't think it's going to affect the rest of the lesson. This is just kind of a discovery exercise. Now in part C here, they want me to use the Pythagorean theorem, and that's legal because it's a right triangle, to write the equation of the circle. So I'm going to say, I'm thinking a squared plus b squared has to equal the hypotenuse squared. So we could switch our a and b. It's no big deal. I'm going to say x minus 4 is my a, and I'm going to say y minus 2 is my b, and that's going to equal 25, or 5 squared. That, ladies and gentlemen, is the equation of a circle. You'll notice that there are 2 squared quantities, one right here and one right here. But this certainly fails the vertical line test, and we've proven that there are quadratic relationships that are not functions out there. The next thing they want me to do is they want me to show algebraically that this point, 1 comma negative 2, which is right there, we're going to prove that it actually lies on the circle. But we got to do it algebraically, not graphically. So I'm going to substitute the 1 in for x and the negative 2 for y into this equation I just wrote. So let's bring it up here. Substitute the 1, and then we're going to substitute the y value, and we're going to see if that equals 25. So I got negative 3 squared plus negative 4 squared equals 25. That's 9 plus 16. Does that equal 25? Yes, it does. 25 equals 25. Here we go. We just proved it. All right, on this slide, we've just finished our discovery exercise. Now it's time to cut to the chase and talk about the general form for the equation of a circle. Now, assuming the circle has the center at hk and it has a radius of length r, the general form of that circle is going to look just like this. The quantity x minus h squared plus the quantity y minus k squared equals r squared. That plus sign is mandatory every time you have a circle, okay? So don't forget your plus sign. On that last problem, on the last page, they said that the center was at 4 comma 2, and they said the radius was 5. And after I used the Pythagorean theorem, do you remember what we had? We had x minus 4 quantity squared plus y minus 2 quantity squared equals 25. And you could see how that matches up with the general form. We had an h value of 4, we had a k value of 2, and we had an r value of 5. So it matches up perfectly. All right, we're going to tackle a multiple choice question here. And they said, hey, which of the following equations would have a center of negative 3 comma 6 and a radius of 3? Well, I'm just going to remind myself what that general form was on that last slide here. And let's see, that's equal to r squared. Okay, now just by judging here, I could see that h is negative 3. I could see that my k value is a 6. And I could see I've got an r value of 3. I'm just going to take those three values and substitute them in. So let's see, I'm going to substitute a negative 3 for h. I'm going to substitute a positive 6 for k. And I'm going to substitute a 3 for r. And then just a little bit of cleanup. Of course, the two negatives there do make a positive. And then we've got y minus 6 quantity squared equals 9. So who do we match up with? Looks like choice number 2. Yes, yes, yes. All right, we're going to do some serious rapid fire here. This time they've given us the equations ahead of time, and they want us to identify both the circle's center and his radius. What I did is I imported this equation right here just to remind ourselves what the general form looks like. And I'm going to go pretty slow on these first couple. Like, I see that h is 2. I got a k value of 7, and my r squared is 100. So that means the center is at 2 comma 7. And that means the r value has to be a 10. Okay. On this next one, we've got h is 5. I've got a k value. Check this out. The k value is actually negative 8, and my r squared is equal to 4. So the center is going to be at 5 comma negative 8, and the r value is going to be a 2. So you see, I'm very disciplined with these here. I take my time. Now nothing's being added or subtracted to the x, so I've got an h value of 0, I've got a k value of 0, and I've got an r squared of 121. So the center is 0, 0, and an r value or radius of 11. All right, we'll go a little faster now. Let's see. I've got h is equal to negative 1, k is equal to negative 2. Hopefully you agree with those negatives. R squared is equal to 1. So my center's at negative 1 comma negative 2. And if I take the square root of 1, I do indeed get 1. All right, I've got an h value of 0. I've got a k value of 3 and an r squared of 49. And so I'm thinking the center's at 0 comma 3 and the radius is 7. All right, let's see. I've got a center negative 6 comma positive 5, just negating those rascals. Now they did say if my radius is not an integer, we'll just express it to the nearest tenth. So if r squared is equal to 18, I'm going to take the square root. Well, the good news is I just got 2 slides to go to show you tonight, so you're close, but I tell you what, these last 2 slides are big bears, so buckle up and get ready to settle in here. I'm going to work on the linear equation first, and they want me to solve this system graphically. The word system just means we've got 2 equations here. When they say solve, that means we're looking for the intersection points. All right, we're looking to see where these 2 graphs intersect. So I'm going to tackle the linear one first, and I'll do that one in red. I've got a y-intercept of 4, and the slope is 3. So I'm just going to go up 3 units over 1, up 3 over 1. And then instead of going up 3 over 1, I could start with my y-intercept here and go down 3 over 1, down 3 over 1, down 3 over 1. Of course, the other alternative there is I could simply have plugged that function into my calculator and gone to the table of values to assist me. All right, in blue, I'm going to work on the circle. And I'm going to set myself up here, and I'm going to say the center is at negative 2 comma 3, and if r squared is equal to 25, that's going to force my radius to have a length of 5. So left 2, up 3 units is my center, and then what I'm going to do is I'm just going to walk 5 units to the right. I'm going to walk, starting with the center, I'm going to walk 5 units down. I'm going to start at the center, walk 5 units left. 1, 2, 3, oops, didn't go far enough. Okay, gotta go a little further. Then up 5 units. And here's where you gotta be really careful. And I'm going to do the best I can here. Yeah, I'll tell you what, I've done worse anyway. It's not my best circle, but I've certainly done worse. So anyway, we said solving means go grab those intersection points, and we clearly have 2 intersection points. And with the assumption that they're going to be nice, I'm going to label those ordered pairs as this first one's 1 comma 7, I believe. And the second one was negative 2 comma negative 2. Now here's my favorite part of this problem, and I know I'm a nerd, but they wanted us to check our solutions algebraically. Algebraically, means we're going to use a method called substitution. I absolutely love this method. I'm going to take my linear equation here. I'm going to take the quantity 3x plus 4 and I'm going to substitute it into y. I'm sure you remember doing something similar your freshman year. We're just going to go ahead and get the rust off. And right here I'm going to make my substitution. 3x plus 4, it goes in for the y. Now don't forget, after the y there's still a minus 3 right there. Quantity squared equals 25. Love doing things algebraically. Love it, love it, love it. We're going to see, hopefully, if we get the same solutions when we're all done. All right, a little cleanup here on that second grouping. Combine some like terms, and I get 3x plus 1 quantity squared. And boy, do we got a double dose of foiling here. X squared plus, let's see, outer and the inner give me 4x. Last times last gives me 4. All right, a little more foiling. 3x times 3x is 9x squared. Outer plus inner gives me 6x, and last times last gives me 1. Combine some like terms here. X squared and 9x squared is 10x squared. Let's see, 4x and 6x is 10x. I got 4 plus 1 is 5, but I got to subtract the 25, so I got negative 20 equals 0. Now, as far as solving this quadratic, we're always going to look for that GCF if it allows us, so I'm going to factor out the 10. And dividing every term by 10 gives me x squared plus x minus 2. Now, anytime your GCF's a constant like this, you can literally throw it in the garbage. Essentially, you're dividing it to the other side, but 0 divided by 10 is still 0. And then just factor it the same way you'd always factor a trinomial, trying to think of two numbers that add up to a 1 and multiply to a negative 2. So I'm thinking positive 2 here, negative 1. Scroll down just a little bit and tee that puppy up. And we got x equals negative 2. We got x equals positive 1. Now you need the corresponding y value. So now recall, the linear equation we had was y equals 3x plus 4. And what I'm going to do is I'm going to substitute. I'm going to take this negative 2. I'm going to substitute into this x. And let's see, 3 times negative 2 is negative 6 plus 4 is negative 2. Now substitute the 1 in there, and you'll get y equals 7. So guess what, ladies and gentlemen? These are the same ordered pairs we had earlier when we did it graphically right here. So we've got a perfect match, a great check, great check. And that's really the key to being successful on the Regents exam, is being able to solve these problems both graphically and algebraically, something we'll talk more about continuously throughout the year. All right, the last big bear of the night involves completing the square. And so we had our hands full with that a couple nights ago, but we fought the good fight, we persevered, and we were quite successful by the time we were done with it. But I'm going to use that technique to rewrite this. Now, it is a circle. The reason I know it's a circle is because there are two squared quantities. I have both an x squared and a y squared. So that right there tells me it's a circle. But it's clearly not in standard form. And by standard form, I am referring to x minus h quantity squared plus y minus k quantity squared equals r squared. Remember, that plus sign in the middle is mandatory. It should always be there. So I'm going to try to get this bear to look like that one right there. And what I'm going to do here is I'm going to complete the square for both the x's, and I'm going to complete the square for the y's as well. We're going to double up on this process. So here's what I've got. I'm going to take the first two terms, x squared plus 10x, and then what I'm going to do is I'm going to add a perfect square, and I'm going to subtract that same perfect square. Okay? And then we'll pick up where we left off after the 10x. We've got plus, don't forget that plus, y squared minus 2y, and then I'm going to add a perfect square, and I'm going to subtract a perfect square, and then, of course, the whole equation is equal to 10. Do you remember how that completing the square goes? It says we're going to take half of your b term. Now, right now, my b term is a 10. If I take half of it, I get 5, and I want to square that. So I'm going to add 25, subtract 25. And then I'll do the same thing for the y's. Now, right now, for the y's, my b term's a negative 2. If I cut that in half, I get negative 1. And if I square that, I'll end up with adding 1 and subtracting 1. Now, I need you to be very organized and careful here. We're going to focus on... Let's see, I'm going to find a new color here. Grab some green here. All right, focus on the first three terms. Just factor those guys. Remember, it should be two identical binomials, and I believe that x plus 5 times x plus 5 works. And then, let's see here. How are we going to handle this? Do you see this minus 25? I'm going to move it to the other side of the equation, and to move it over, we're going to add 25 over here. And then, I'm going to focus on my y's, bring that plus sign down, and factor those y's, and I'm going to get y minus 1 times an identical y minus 1. And then the last term sitting there at the end, again, I'm going to move it to the other side, and I'm going to add 1 on the other side. So if I combine those three terms, I'm going to end up with a 36. Last but not least, let's condense. So I got x plus 5 quantity squared plus y minus 1 quantity squared equals 36. Ladies and gentlemen, it is time to celebrate. We have successfully rewritten this equation so that it's in standard form for a circle. And let's identify the center. The center of the circle is going to be negative 5, comma, positive 1. And if the r squared is equal to 36, that's going to give us a radius with a length of 6 units. So, congratulations on finishing the video with circles. Good luck tomorrow, and we'll see you.